All right, so this is our momentum video. We're going to talk about what momentum is, some important things to be mindful of when you're thinking about this, and as well as some pertinent examples and how to solve problems regarding momentum. So impulse and momentum. We're going to focus on this one right here, and in our second lecture, that's when we'll talk about something called impulse. So when you think of momentum, when you hear that word, I want you to kind of think to yourselves what you think about when you hear this word, what it means, or maybe like something that when I say momentum, this is what automatically pops into mind. So I want you to think about that. So what is momentum in terms of physics? So it's symbolized with a lowercase p. It is the quantity of a motion an object has. So linear momentum or momentum is defined as mass times velocity. So here is your first formula. Lowercase p, momentum equals mass times velocity. The unit is, it makes kind of sense. It makes sense. So you have your units for mass times your units for velocity. Knowing that velocity is a vector quantity because it can have a direction, so that means your momentum will also have a direction too. So like if you have a negative velocity, which we know what that means your momentum is going to be considered negative as well. So when we say that a ball rolls down a hill, we're saying that it's gaining momentum. So we'll look at this video. You can watch it later on. I'll post a link for it. But yes, so when a ball rolls down a hill, it's gaining momentum. But what does this mean? So when you say something's gaining momentum, the more momentum it has, the harder it will be to stop as it's coming towards the ground. Because the velocity is increasing as it's going down a hill, so to speak, because the force of gravity is accelerating it. So you can increase the momentum by increasing the mass, or you can increase the momentum by increasing your velocity, which could be potentially due to gravity. So remember that since it's P equals mass times velocity, if I increase my velocity, I can also increase my momentum if I keep my mass the same. If I increase my mass, I will also increase my momentum if I keep the velocity the same. So this is the video for it. So if you consider a car in motion, it also has momentum. Again, if you have more momentum, the more difficult you'll be to cause you to stop. So think about it next time when you're hitting the brakes on your car, or letting friction slow your car down eventually by taking your foot off of the gas. Because your car has a certain mass, or maybe it's going really, really fast, it's going to take more of an effort to get it to stop. So here's a video. It's a car trying to stop at 60 miles per hour and then at 100 miles per hour. Then you'll see what the difference is in terms of how long it takes, or the distance it takes for it to completely stop, because it has more momentum, because it's going faster. So using momentum in parkour, you see people do this all the time. I can imagine y'all probably doing this as well. But so the guy to the right, what he's using is he's going to take his horizontal momentum and use that to carry him vertically, so to speak, as far as he can go. And he has to max out the force over a short period of time when his foot hits the wall so he can go as high as he can. And we'll talk about more of this when we get into something called impulse. So example problem number 1. We'll have 3 of these, and then that'll be it for this lecture. You're running north at 3.0 meters per second. If you have a mass of 80 kilograms, I kind of wish I did. That'd be kind of nice, not gonna lie. What is your momentum? So remember, when you're solving these, you got to identify first what your variables are, your formula, your work, and then your answer with the unit boxed in if you need a direction, etc. So if you're running north at 3.0 meters per second and have a mass of 80 kilograms, what's your momentum? So this is my velocity, this is my mass, this is my momentum. P equals m times v. So 80 kilograms times 3.0 meters per second, plus meters per second. So 80 times 3, 240 kilograms times meter per second. So then my final answer will be 240 kilograms times meters per second north, because I said I'm running north, or you're running north. So you're falling out of an airplane. So here's your plane, sort of. This is you fall out. Sorry. Before opening your parachute, you hit a speed of 100 meters per second. Or if you're going downwards, this could be your velocity, negative 100 meters per second. What is your momentum, P, if your mass is 80 kilograms? So P equals mass times velocity. So 80 kilograms times a negative 100 meters per second. So I have negative 8,000 kilograms times meters per second. Example number 3. Suppose that you're in an 80 kilogram race car going 200 miles an hour due east. If you have a mass of 60, what is the total momentum? For this, all you need to do, so you have 2 kilograms here, 2 masses. Just keep in mind, I'm asking for the total momentum. So all you need to do is just add the masses together, and from there, you can get your momentum. So my total mass is 800 plus 60, so 860 kilograms. I give you a speed, unfortunately, in miles an hour, so what you need to do is you need to convert those miles per hour to meters per second. So remember that in 1 mile, 1,609 meters. So I'm going to take my 200 miles per hour, convert this to meters per second. So 1 mile, 1,609 meters. 1 hour is 3,600 seconds. So 200 times 1,609 divided by 3,600. This is approximately 89.3 something meters per second. My momentum, P total, is mass total times my velocity. $860 kilograms times, I'm going to take this whole number on the calculator. It's like 89.38888 blah, blah, blah. Times 860. So it's going to be 76,874. Let's see. So we're not dealing with sig figs anymore. So let's just make sure we're good with our units and our numbers. So 76,874 kilograms times meter per second. All right, so that's it for now. If you have any questions, please let me know.